2 minutes. Or
We can pull that off. I mean, I made the slide deck in like 3 minutes, so. It only took like 5 years to actually get the code merged, so 2 minutes should be quick. So time optimal trajectory generation was actually mentioned earlier today by Dave as one of the things that got done in the last year. So most of the planners obviously output trajectories that need time parameterization, right? There's no time involved in the actual planning. There's an original plugin that came with MoveIt that's been there since the PR2. The PR2 doesn't have the greatest controls in the world, so it doesn't mind if like the things all violated in the velocity and acceleration limits because it just won't listen to it. So unfortunately, when your arm's very velocity sensitive, you get really terrible movements out of it. Back at the first, I believe it's the first World MoveIt Day, was 2016. And yeah, and so we were down at Fetch, and Dave and I basically decided we were going to merge the MoveIt repo that day, and like then we had to consolidate all the tickets afterwards. So I created a ticket back then, so 3 years ago. Finally created a PR to answer the ticket back in 2018, then never got back to it. And then Henning Kaiser at Technik actually went ahead and made that pull request actually happen by finishing off the comments that came back from Dave. Okay, now I just need to figure out how to get to the next one. So how to actually use this, right? It's actually super simple. Just add the word optimal, and you know, in OMPL planning pipeline.launch.xml. So what this is, it's in, I don't know why I said better, but it's in Melodic and Master Branch. This is actually based on some work for Tobias Kunz and Mike Stillman. They put this out in 2012, and we finally got it now in MoveIt, so that's pretty cool. What it isn't, as has been said multiple times today, it's not jerk limited. So it will actually listen to the velocity and acceleration limits. It doesn't care about jerks. So if you're running a big industrial arm, probably still not the answer for you. It may lock up on you because it thinks you've given it a bad plan.
great. Next, so Christian Henkel. You sent me this, right?
Yeah, thank you. Yeah, I just don't want to have a look at Mike's dogs. You know, I'm more of a cat person. And I've seen Madagascar. So there we go. I just want to plug quickly my tool that I presented already at last year's World Industrial Conference. It's called dockerros, and it's basically just Docker with ROS. And then it's all good, right? Basically, the idea is that you have a method to deploy software to robots relatively seamlessly. It's something that we used a lot when we worked with big fleets of robots, and we basically, most of the time, handcrafted some kind of Docker images that we then put on the robots. I mean, you can expose the hardware of the robots to the Docker image, right? Yeah, and what the tool does is it basically kind of resolves the dependencies of your whatever Docker package, ROS package you have, as we do, and creates a Docker image for you that contains all this package needs. And so then it's like a library, and on top of this library there's a CLI, as you do, and you can, for example, do dockerros, and then you, for example, say dockerros build, and after this build, you then put the ROS command that you would want to run in this container later. And then you can do fun like this, like in your development workspace, you do dockerros, run, ROS run, whatever. And like here, it creates your image, and then it's running, as you can see, and then it starts all over because it's GIF. Yeah, you can then also refer to this kind of, this image is then uniquely identified by whatever the ROS command is that is running in it. So you can also say dockerros stop, ROS run, hello world, Talker in this case, which is kind of counterintuitive, but that's the way it is. Yeah, it will not only work with this kind of automatic discovery. It can, of course, do this automatic discovery for system packages. That's fairly simple. As I showed here, it can do it for workspace packages, but you can also just create a Docker file, a custom Docker file.
Great, thank you. Limor, did you want to do one? I thought you, yeah.
I'm Limor from Mov.ai. This is nothing to do with MoveIt. It's something we've been working on for the last couple of years. We're a startup out of Portugal, 25 engineers. And this is just a quick snapshot of one of the things we're doing with ROS. It's an alternative launch system. So what you can see here is basically an alternative to ROS launch. So it's a graphical interface. Those lines are remaps, and the nodes, the purple one, for example, in the middle is AMCL. The blue ones are custom nodes that you can create in the browser, in Python, in Cython, and it can run on multiple protocols. You can create callbacks to ROS1, ROS2, and other protocols. And then the remaps are done this way. And we're looking to somehow make this useful in Python contexts, and still working on it. Thank you.
Hello, hello.
Hello.
Hello. Okay. Give me a second. Where's my mouse? Sorry, I can't find my cursor. Yeah, I'm going the other side, but I can't find
It's about
it.
halfway up the mountain right now.
Okay. Give me a second.
We're going to start your time.
Sorry. Okay. So I made a last minute request of a lightning talk. So yeah, let's get started. So right. So for me, right, we are working on. Okay, I'm from Technik, right below, and we are working on this project called RMF, and it's a research initiative from Singapore, and then these are the organizations involved. And what is RMF? So it's a robotics middleware framework, and we are trying to enhance interoperability between IT systems, robot fleets, robot work cells, and healthcare is obviously a job that it can be applied on any industry. So RMF in overview is this, and today I'm focusing more on the robotic work cell, which applies for ARM, and we can use MoveIt for this. So that's one application that we are working on is this department with is a very manual process that workers need to go there and then pick items and deliver it to operation theater. So, and this is a solution that's a very high level solution being proposed. Then we develop this kind of solution. So, which involve ROS and ROS2. So ROS2 is to create this kind of work cell which is able to communicate with other work cells or fleets or other systems. And the robotic aspect of things are still in ROS, and we are leveraging on MoveIt. So, yeah, and to show you, the video, we did a very simulation to simulate this kind of the process, and it's using a camera to detect the position, and then everything is dynamic planning and MoveIt. So for me, MoveIt is quite a new thing, and then I think it's quite convenient for me to use as a beginner. Yeah. So that's it, and we hope that we can create more progress and eventually open source it. Thank you.
I want to point out that that was exactly 2 minutes. Yeah, you nailed that one. I was watching the clock. Like, do you want to?
Hi, I'm Steve. I work for Samsung. I do open source stuff. Talk to me later if you want more details on that. So last night at the AutoWare thing, I started talking to Jeff and a bunch of people over there about trying to minimize the amount of maximize the amount of reuse and common components across AutoWare navigation. And that kind of got started to get me thinking about some of the different higher level application type projects in the ROS ecosystem where there might be a lot of things that we can collaborate together on, so that we're not having the very limited number of maintainers that exist, wasting their time on similar types of things across a lot of projects. So we talked about over here with Fergs about Octomap and MoveIt, and one of my personal interests in navigation is kind of getting rid of this 2D cost map, so we're doing 3D planning as well. And obviously AutoWare cares about these kinds of things. But yeah, if you know about any other things within MoveIt or in other communities that you think might be interesting for MoveIt, that there might be some sort of like cross-ecosystem collaboration, let me know, and I'd love to either make those connections or help kind of run those projects through the TSC working groups. Yeah, thanks.
Thank you. I definitely appreciate the shout out to Fergs. Fergalicious. Right. So at that point, if anyone wants to get up and give a lightning talk, those were the people I was able to coerce into doing it. So if anyone else feels coerced, if not, we could also call it good. Keep the schedule on.